Hi guys, here we are again. So, as we started yesterday, as we spoke in last video, so today we are going to start solving differential equation. Okay, first order and first degree differential equation with the variable separable method. So in this method, all you need to know is that you have to any first ordinary like this. Okay, first order. Okay, and first degree odd. Okay, what we mean by odd we mean ordinary differential equation. Okay, this any first order and first degree ordinary differential equation can be solved by separable. Okay, applying separable method. Okay, only if it can be reduced, okay, in this form, h of y dy, okay, dy dx equal to f of x. Or you can say this expression is the same as you say dy dx is equal to f of x times h of y. As long as you can get this, okay, as long as you can write the function in this form, okay, so that it will allow you to separate, okay, dy with the function of h y and dx, okay, with the function of f of x. So we can say that this is a differential equation that can be solved with separable method. Okay, because here what is coming next? So what's coming next is just differentiation of this guy. We have just this differentiation like this. If you can write like this one or this one, if you can say if you can reduce dy upon dx equal to in a product of f of x and h of y, okay, where f of x and h of y are originally like are purely algebraic functions. Okay, yeah, just like this. This is a function of x and this is a function of y, only of y and only of x. So you can solve this exercise in this method right now. Okay, now let us try to solve one exercise so that you can have a clear mind on this concept. Suppose we have, okay, an expression like this, a differential equation like this. Okay, this is y upon x dy upon dx, okay, equal to root, okay, this is root, let me write down here, root of 1 plus x squared, then plus y squared, plus, okay, plus sorry, plus x squared and y squared. Okay, suppose this expression. Now my main objective here, it is to make this equation look like this. Okay, look like this. Okay, or like this one. Okay, I have to make in this expression, okay, I have to try to reduce this expression in an expression like this, in a function of x, okay, time a function of y, and it must be equal to dy dx, so that I can just split and separate dx, differentiation of x, with f of x, and differentiation of y with a h of y. Okay, just separate this one. Let us try then. Okay, what we are going to see here, we have to do, okay, y dy and here x dx, it will be equal to, yeah, now look deeply at this one. We can just factorize this one and this one. These are common factor. Okay, we are here we have 1 plus x squared plus common factor, this will be 1 plus x squared too. Now here we can see directly that this can be directly just, we have common factor 1 plus x squared. So 1 plus x squared is a common factor. then we'll get 1 plus y squared. Okay, and this is y dy upon x dx. So the next thing that we have to do is just to separate. Okay, we have to separate in this form, in this way, like you can see that dy dx is equal to f of x and h of y, where f of x is a function of x only and hy is a function of y only. Okay, here we have a function of y only, we will just put them together. Okay, so where you see it will be like this one, root of 1 plus x square. This x is dividing, can go there, multiplying. Okay, and this y is multiplying, go there, dividing. This will be function of 1 plus y square. Okay, all upon y. Okay, okay, this is the expression. So this is dy upon the x. Now that we could see this is a function of x only and this is a function of y only, so the next step is just to put together f of x with differentiation of x and f of y with differentiation of y. Then it will be something like this, y dy and root of 1 plus y square. Okay, it's dividing, go multiplying, multiplying, go dividing. And here I'll get x root of 1 plus x square, and here dx. Okay, okay, now that I could separate this one, I have just, the next step is just to apply integration. Okay, just apply integration both sides. Okay, now what you have to do to find this integration, you can apply just a substitution method directly. Okay, substitution, just make this one, this, if you see this integration, this y is differentiable with respect to this one. If I differentiate 1 plus y square, I can get y, and the same happen here. If I differentiate 1 plus x square, I can get x. So just go directly and see. Then here you have just to do, it's upon you, you can just make this substitution. 1 plus y square is equal to u square. Okay, because I don't want to work with this root, that's why I put u square. Okay, then here you can also do the same. 1 plus x square is equal to, it's upon you, you can call this t square. Okay, so differentiate this one, then apply substitution to this guy. Differentiating this one, what we are going to do, you are going to have dy, 2y dy is equal to 2u and du. Okay, here clearly you can see that dy, okay, y dy will be equal to u du. It's okay, nice. Now for this second member, do the same, differentiate them, it will be dx again, okay, is equal to 2t and here dt. So 2 will be cancelled out, so x dx will be equal to t dt. Then what you have to do, just substitute this expression in there. Where you see 1 plus x square, put t square. Where you see 1 plus u square, put u square. So let me write here though. So it will be, okay, changing everything. Okay, changing everything, what you're going to have, as you can see here, okay, this is what we ended in. Okay, we are just changing what we are going to have. We are going to have this directly, integration y dy is equal to, just see the y dy is equal to u du. So put here u du upon, see there, okay, 1 plus y square is equal to u square, so it will be root of u square equal to, the same will happen here. So x dx, we know it is t dt, just see that, x dx t dt, and 1 plus x square is equal to t square. So what we are going to have here, this will be t dt, okay, t dt time, okay, let me this one, let me, okay, let me arrange this way, okay, in a better way. It will be u du upon root u square is equal to root t square, okay, t square root then t dt. Okay, this is what we are getting. Now we just know this will be only du, okay, and here it will be t square, integration of t square, because this will be cancelled out with this, and this one will be cancelled out with this also. So u upon u 1, t times t square, and here dt. So what else you have to do? Just find this integration. This will be equal to u, and this will be equal to t cube upon cube plus c. Okay, now what you are going to do here, what you have to do, just substitute them. Substitute what is u. You said that u is equal to 1 plus y square is equal to u square, so u will be the root, okay. Here now we know that u will be the root of 1 plus y square equal to, here it is the same, just t. What is t? T will be, okay, 1 plus x square, and here 1 by 2. It's all into the power 3 upon 3 plus c. Okay, yeah, and this is actually our differential equation finish. This is the equation that we are looking for. Okay, so we solved applying separable method for first degree and first order differentiation equation. Okay, so you can arrange this guy, okay, you can just go deep and deep, just find the common denominator and do whatever you feel like. Okay, now this is the general solution for this exercise. I hope you can understand this, and we are going to jump for another one.